One thing I'm a huge fan of in my career, since I've been doing programming for roughly 30 years, been working in technology for even a little longer than that because I worked as a teenager. And I think you have to delete what you know. And that's really a foundational skill. Maybe every 6 months or every year, something that you already know has to be deleted. It's almost like if you have vegetables in the fridge, you have to throw some of them out if you don't have them eaten quickly. Similarly with technology, you have to constantly be like reassessing what it is that you are currently doing and changing it. So let's talk about why I currently have deleted Python for Rust. And it really doesn't matter to me if it's popular or it's not popular. I know it's a better technology and I live my life according to what I think is the best choice. So let's go ahead and dive into it. First up here, memory safety. This is one of the really cool things about Rust is that I know the language has been designed so that memory safety is there at compile time. There's also zero cost abstractions, so I don't have to worry about all these weird things people are doing with garbage collection with Java. And then in production, you can see that I'm able to reduce the CPU as well. So just by default, you have amazing memory safety without the runtime overhead by using Rust, where Python has garbage collection, Java has garbage collection. These other languages have these penalties that you have to pay for that. Another one that's an interesting component of why I like Rust is predictable performance. What's really interesting is if you bring up a example of why Rust is faster than Python or Go is faster than Python, etc., what's the very first thing people will say is, oh yeah, but if you just jump this hoop and if you just jump this hoop and this hoop, of course, but couldn't you also make Rust jump those hoops as well? The real thing is, what is the default performance? It's like saying I have a 1968 Chevy Suburban and in fact it doesn't use that much gas because I live a mile away from work. Well, still you would save a lot of gas even over the lifetime of the car if you use an electric vehicle or a vehicle that had 100 miles to the gallon versus 8 miles to the gallon. You care about the default predictable performance, and you get default better predictable performance with Rust than Python. It's obvious it's a compiled language. If we take a look at the global interpreter as well, this has been a huge bottleneck for Python where true threads don't work. And if you're dealing with concurrency on virtual machines, for example, this really comes into play because you have idle cores that you could use. Also, direct hardware access when needed, and the constant time operations are going to stay constant time because you have this predictable performance. Another one is concurrency without all of the weird problems that happen. Concurrency is one of the most difficult paradigms of programming, race conditions, for example, but the type system itself in Rust is designed to prevent the data races. Also, the async await pattern actually works well, and it has a real parallelism, not just concurrent IO. And that's really the thing about Python versus Rust is people talk about, oh, well, yeah, but sure, we can do IO and we can do network IO and disk IO. Yeah, but what about all IO? What about all concurrency? Those are the things that we care about. Again, the default predictable performance of Rust is superior to Python. Next up, we have the type system. Python doesn't have a type system. There's this optional, type annotation, which by itself should tell you there's a problem with Python. If types weren't important, why would all of a sudden people start using things like Pydantic and all these other optional libraries if it wasn't a problem? It is a problem, and that's why people are bolting on these features later. So the type system is going to catch a lot of bugs. And in Rust, if it compiles, it usually will work. There's not going to be like a type error at 3 a.m. in production. And the type inference also means there's a lot less boilerplate than languages like Java or C++. And in addition, if you're inside of an editor like IntelliJ or Vim or whatever, you can get this really good experience with the type system. Now, a big one for me next is package management. Python, in my opinion, has one of the worst package management systems that's currently in existence. One of the reasons why is there's so many different ways to do it. Do you use virtual environments? Do you use Conda? Do you use UV? Do you use Poetry? Like there's just an explosion of different things. And especially the slower ones have been really a problem. And then also this idea that some strange third-party company is managing my packages. Like what is that? Why can't the language itself just give me something like cargo where it's deterministic? I just say cargo new. I create a structure. There's a cargo.toml file. As well, the dependencies are versioned properly. And you don't have this like, oh, wait, it worked on my system, but it doesn't work on your system problem, which is really, I would say, a foundational issue with Python is that the standard library is very good. I would say that's the thing that Python has done very well. But once you start to get into packaging, wow, anything can happen. And you have this real problem with, well, it worked on my machine. Now, the other one that we should talk about is the systems programming capability. So you can make direct calls without wrapper overhead. You also have embedded system support. You can do kernel module development as well. So we know the Linux kernel, people can develop with it. So it's a deep language for doing systems programming. Also, production-ready performance is another feature that I like to talk about. So you get native executables. So you can compile down to ARM. You can do x86, right? You have the ability to go to all these different targets, and then the runtime is very tiny, and you can get binaries that are 5 megabytes. And so you're able to build these really nice, efficient production-ready systems. Also, small Docker images. If you look at maybe a default Python image, maybe it's 200 megabytes, but with Rust, you could have one that's 10 megabytes. You can make these very tiny production-ready systems. In terms of modern tooling, we also have, with Python, going to the next reason here is you have built-in tools like Rust format. So Python has Python Black or these other kind of, linting and formatting tools. It comes with Rust. The language itself has built-in with Cargo the idea of formatting. There's also comprehensive documentation tools as well, first-class IDE support. So the modern tooling with Rust is just tremendous, right? You can just use Cargo, Rust format. You can say Cargo Clippy to do linting. You can do Cargo build, and it will build by default a debug binary, and then you can do Cargo build -- release, and they get this super optimized performance binary. If we go to the next reason here as well that I like Rust, it would be the growing ecosystem. We're really still at the early days of Rust, and you can see that there's web frameworks now that match the ease of Python, very intuitive. Machine learning libraries are starting to emerge. We see bindings to things like PyTorch. We see large language model development emerging. We also see that there's even things that Python is never going to be good at, which is GUIs, are very good with Rust. And you can see things like GTK, Qt, all these GUI frameworks work very well. And also the cloud native tools are proliferating as well. If you look at Amazon, for example, AWS Lambda is built in Rust. It's an amazing tool for that. We also see that building Rust AWS Lambda tools are also a great pattern. So you see, like, why would I use a slow language if I'm getting charged by the CPU time and memory? Why wouldn't I use the most efficient tool? And then if we get into the cost efficiency, this is another one that's important to talk about, is that it can be much, much more efficient to use Rust. And ultimately, that could be the only reason that you use Rust. And let's get into a couple more things here that I find useful. One of them is this idea that you build once and you run forever. A lot of times people are confused about what production software is. They're focused only on how easy it is to build code. And it's true. Like if you build something with Python, the language is pretty intuitive, but do you care about building cups or do you care about washing cups? And this is the wash the cup principle, is the initial design is going to pay off over the lifetime, right? If you have a really cool cup you built, maybe it takes you a day to build a cup, but then you get to use that cup for 10 years. Isn't that a lot better than being able to easily make cups that only last a day? Like, for example, disposable cups. And then with refactoring, it's driven by the compiler, right? It's not some kind of runtime roulette where you're like, oh, wait, does this work? And you're just kind of guessing and trying things inside of a Jupyter notebook. The compiler itself says, look, this is the truth, and this is when it works. Also, the technical debt is caught at compile time. So you're not pushing that debt into production. I've worked in my career at organizations that had hundreds of millions of dollars put into them where there was code that was in production that was non-executable. I remember I went to a manager at the time and he said, "Oh, what's the big problem?" It's like, well, the problem is that you put technical debt into production. That's the problem. Rust is able to catch that technical debt at compile time. So you can see that you're spending a lot less time on runtime issues. You can also think, if I get into another reason here, of the compiler as effectively like a senior engineer. So it would catch 90% of what a code review would catch. You don't get these undefined is not a function. Also, these edge cases go away. You can eliminate entire classes of bugs just by using a compiler. So that's a real weakness of these scripting languages that don't use a compiler, is that you do want a compiler. Why would you not want a compiler to check all of your bugs? And then finally, to wrap up, I would say the deployment certainty is probably the biggest thing. You have a single binary without having to do with anything else. And this is amazing to have a single binary for deployment. You're not in dependency hell in production. Cross compilation, again, if you want to compile to ARM, not a problem. And you can cut dramatically the cost of using things like cloud computing. So I guess in a nutshell, I think Python is great for the standard library itself with no packages. Like, for example, if you want to run, HTTP or something like that, cool, right? I mean, and I think that's the issue with Python, is this idea that it should be globally dominating, this kind of colonial mindset of like, hey, we have to colonize everywhere and they have to do everything that we say. Well, what if Python was good enough and it has some things that it's good at, like the standard library is pretty good, or using Python to write a small little script that doesn't require any kind of third-party tool, good. Or maybe you want to play with it in a notebook, great. Those are some of the things it's good at. It doesn't have to be good at everything. For production systems that want to scale, I think Rust is the future, and the learning curve is definitely worth it. So go ahead and give me your thoughts. Those are some of the reasons why I like Rust, and let me know.